to break free. Oh, ready for the videoing. Sorry, I didn't realise. We'll, oh dear, got to do some cleaning there. Answers to the mechanisms questions. 3 separate videos, be 3 separate short videos with the answers. Free radical mechanism video, electrophilic addition, nucleophilic substitution, all year 12 focused, and we'll have the answers. I'll see you after the edit very soon. Welcome back to the answer, well, the third of the answer to the mechanisms questions. Nucleophilic substitution, little change of outfit. It's because there was exercise in the middle of the day. So, nucleophilic substitution, there were 6 questions, and well, mechanism for the first one, 1-bromobutane, primary, therefore this will be the what we have called the SN2 mechanism quite correctly. So the OH comes in and pushes the bromine out in a sort of shunt. In I come, out you go. And the result is this chemical over here, which happens to be butane mono. Now, one of the things I didn't mention before is that when you come in, you push, if you look at these, they flipped. Now most of the time, well certainly in year 12 that makes no difference whatsoever, but there is a consequence to that in year 13 when you have a certain type of compound. I'm not going to say about that now, but you just need to be aware that there is a further additional thought once you get further into A-level chemistry when you come to the organic part and the mechanism part. Now B, you might notice the edit there, that's because there was a little camera person operator incident. B, drawn very straightforwardly, you just draw a cross and put the BR on the cross, one of the arms of the cross. It's tertiary. Here's the 3-dimensional drawing of it here with the 3 CH3s. Notice that the CH3 is backwards over there because it bonds through the C, not a hydrogen, which it would look like if you did it the other way. Tertiary, with all the stability caused by the alkyl groups, methyl groups in this case, pushes electron density towards the bromine. Bromine then, under the conditions of the reaction, the bromine will leave as bromide, leaving you with a tertiary carbonium ion, and then the OH just goes and joins on, and you get the alcohol produced, the OH then literally swapped for the Br, which is what substitution means. Like I said in this one, there is also a consequence in year 13 to doing this mechanism in terms of a particular facet of isomerism. Not going to talk about that in year 12, but you do need to be aware that there is a further step in understanding all of this. So that's A and B. We'll move on to further into the examples. I'll do that because I need to do a little edit whilst I wipe the board and get ready. See you on the other side of the edit. Okay, C. This is secondary. Oh, what does that mean? It means that it does both SN1 and SN2 mechanisms. So if you go through the SN2 mechanism, you end up straight here with the in and out shunt, with the NH3 coming in and the Br leaving. But also it does part of it through a carbonium ion where you end up with a plus there. Don't forget there is also a hydrogen, there's 2 hydrogens on every carbon except for the one with the bromine where there's 1. So there is still a hydrogen attached here. And plus there, lone pair on the ammonia goes in, joins on, and you get, whichever route you go, you end up with this structure here, where the nitrogen, using its lone pair to bond to an H+, equivalent to positive charge because it's now deficient in electrons. What then happens, as we said in the instructional videos, is another ammonia comes along, plucks the hydrogen off, the electrons go down to the nitrogen to return it to the number of electrons it should have, and that means that we have the amine as a structure. So it doesn't matter which mechanism you go in terms of outcome, it does matter which one you've been asked to draw, obviously, if that's the case. But there we have it, going through both mechanisms, same intermediate, same end removal of the H+, which is also called a proton. If you think about it, that's what it is. And then you end up with the amine. And we're going to edit now because we need to clean the board and get D up there. See you in a moment. So here we are with D. Got 1-iodopropane, primary, so therefore the mechanism will be SN2. It'll be the OH, well not OH, water this time, comes in, and the I leaves as I-. Water technically not in, it would be silver nitrate solution at A level. We would say is what we would use to get the water to be the attacking group. It goes in, iodide leaves, and we get this 3 bonded oxygen, 1 too many bonds, lone pair used to make the extra bond, so the oxygen carries the plus charge, then another water comes in, removes the hydrogen, and we end up with propan 1-ol. So it's primary, mechanism is SN2, gradual shunt, didn't do the transition state. Should you want the transition state, you would have to have that carbon there with the OH attached and the iodide attached on longer bonds. And we're ready for moving on to E and then F, and I'll see you after the edit for those. See you in a moment. So here we are with E. Now again, secondary. So we have the choice of which mechanism we go by. CN comes in, Br shoved out. That'll be the SN2 route, and it will take you to this compound here, which is a dinitrile. 2,4, obviously, that's where the bromines were. If you want to go down the SN1 route, you would pop the bromines off, and only a proportion of them would do that. You would end up with a dicarbonium ion, and then the CNs, notice the negative is again, like I said, on the carbon, because that's where it resides, not on the nitrogen. Goes round, joins onto both, so you'll need, obviously, in terms of molar ratio, to do this reaction, you'll need twice as many moles of the nitrile, or well, cyanide ion as it is until it's joined on, as you do the organic, and therefore you get this compound here. We're done. I'll see you for F and then G. So here we are with F, 3-ethyl, meaning that there's 2 carbons attached to this 3rd carbon, which is where the bromine is, so there's 3-bromo, 3-ethyl, and hexane in the skeletal. When you look at that, 1, 2, 3 bonds to carbons, it's tertiary, so this is the intermediate. There's a carbonium, that's a tertiary carbonium ion. And then ammonia comes in. What will happen is once the ammonia is in there, it'll be three there, it'll carry a plus charge, so you then need to do that final thing where another ammonia comes in and removes one of the hydrogens, and you end up with the amine, which you would write as NH2 on there, not all displayed. And then we have F, 1 to go, and then we're done. See you in a moment. So here we are with the last one. Now, that is a nucleophile, but it's not a nucleophile on the nucleophile list for A level, because they do like sometimes to throw you into situations where you have to apply your knowledge rather than just, oh, it's what we already had as knowledge. So, different nucleophile. Did struggle to find one that actually did the reaction I wanted. A lot of these do, when you do similar things to this, they do a different reaction. But this one does do a straight on nucleophilic substitution on, well, here we have iodomethane. Iodomethane is primary, so it's SN2. This will come in, iodide will leave, so we'll end up with iodide over here. It's a different nucleophile to the ones you've met, but it does exactly the same thing, so it ends up joining on there, and you get what would be exactly the same as if you'd had any of the nucleophiles you already knew, It's just the type of compound formed is a new type of compound. Well, it's not that new, it's not completely new, because you have had the word ether mentioned to you, I'm sure, at some point, if you were listening. So it's an ether. And there we have all of the examples for nucleophilic substitution. Thank you for watching, and I'll see you for more Year 12 content in the near future. Bye bye.